Hello, friends. We are podcasting AP Statistics, Section 2.2 in our textbook, and a handful of things I just want to cover and then do some sample problems just to make sure you're in touch with the concepts. First and foremost, we are now talking about normal distributions. And normal distributions are just a special set of bell-shaped curves. They are density curves, so you should recognize this as a normal curve. And this notation where the first number in there is the mean of the distribution, which would go here, and the second number is the standard deviation, which would tell us how far this distance is. And I could keep adding that same distance out each way here and subtracting it here. So first and foremost, you should recognize the notation, what a normal distribution is. The area under here, all this area, is 1, so that if I have a distribution like this, you recognize that these numbers are the number of standard deviations away from the mean that any data point is, that this is the empirical rule. This is sort of our rule of thumb. And you have these ideas right here that you can concentrate on. And if I gave you a problem like we had here, example 2.6 on page 136 in your book. So if you're given just this much information, that this is a normal distribution with mean 64.5 and standard deviation 2.5, that you could take this and fill in all of these numbers. So that's where we start. What we added new was this normal probability plot. So what I want to start by is going to example in your book 240. That's on page 156 in your book. It's a problem about the density of the Earth, and what you have is a list of values that we first saw on page 106 in our book, problem 1.60, by the English scientist Henry Cavendish, and these were his measurements of the density of the Earth as recorded using the density of water. So you got 29 measurements here. And part A of this problem says to construct a stem and leaf plot, which I just copied the one out of the back of the book. Everyone should be able to do this. Remember, we could look at this and use this to find the median, the quartiles, and I could use that to determine what the upper and lower limit of outliers are. So all that old stuff still has to be in the back of your mind. Part B says, now closely follow the 68, 95, 99, 7 rule. Fine. So what they want you to do is find the mean and standard deviation, and then add and subtract the standard deviation and see what percentage of these readings are within 1 standard deviation, 2, and 3 in Cavendish's data. So I have already plugged the data in, and you should all know stat, one right arrow to one variable stats. I'm in L1, so I can just hit enter. So I got an X bar here and a standard deviation. So now I'm just going to add and subtract this number from this number and see how many of those values are in between. Now I want to show you some other little cool things I can do with this calculator. Now that I have done one variable stats, I have an actual X bar and an S sub X in the calculator. So I can do things like this. I can hit vars, statistics is number 5, and there's my X bar. This number is now going to represent the actual mean that I got from Cavendish's data. So X bar plus, and I do the same thing, vars, 5 for stats. The standard deviation is 3. So when I hit enter, that's the upper bound. Now, not done with the coolness, if I go second enter, that comes back. And if I just change the plus to a minus and hit enter, I get two numbers here. This is the lower bound, this is the upper bound. So I can go to my list of numbers here and see what percentage are in between. I could do the same thing. I'm just going to pause and then pop it up there. And by making this plus and minus 2 standard deviations, I get where 95% of the data should be. And if you read this answer right here, you can see that it comes out pretty close. 22 out of the 29, 28 out of the 29, and so on. All right, we're going to hit the normal probability plot part C in the next podcast.